Assalamualaikum warahmatullahi taala wabarakatuh and good evening. Today we are going to discuss about the numerical problem of chemical equation. Last time kita sudah bincang tentang how to balance the chemical equation. Kita akan repeat semula ataupun kita akan lihat semula bagaimana kita nak balance the chemical equation. Sekejap ya. Sekejap. Kita akan lihat semula. Ini semua dalam buku teks. Semua boleh refer buku teks. Pada muka surat. Sekejap ya. Balance chemical equation is on the page 72. Ini minggu lepas kita dah bincangkan bagaimana kita nak balancekan chemical equation. Cikgu akan ulang lagi sekali. Bagaimana kita nak balance chemical equation? You have to remember the number of atom in reactant is balanced with the number of atom in product side. Ini example. Example given is sodium. React with chlorine, produce NaCl. Dekat sini, ini adalah bahagian reactant. Kita panggil dia bahagian reactant, iaitu bahagian bahan tindak balas, and this side is known as product side. Sekali lagi cikgu ulang, you kena ingat bahawa number of atom in product side must balance with number of atom in reactant side. Kita akan tengok di sini dahulu. Kita akan tengok on this side, which is reactant side, we have 1 Na, and also 2Cl. On this side pula, kita ada 1 Na and 1 Cl. So this is not balanced. What is not balanced? The chlorine atom is not balanced. On this side, we have 2Cl, and this side we only have 1Cl. So you kena balance the Cl. Nak balancekan equation, you kena tambah di depan. You tak boleh tambah dekat sini. Katakan you nak tambah NaCl2. You tak boleh ubah dia punya formula. Jangan sesekali ubah formula. Itu akan jadi salah. Kita nak balancekan chemical equation, kita perlu tambah stoichiometry. Stoichiometry is the number in front the formula. So dekat sini kita ada 2Cl, so kita tambah 2 di sini. Now at this side we have 2Na and 2Cl. NaCl is the formula and 2 in front the formula. That means 2 is belongs to Na and also 2 is belongs to Cl. Dia berbeza dengan macam gini. Contohnya kita ada MgCl2. Dua di belakang ini hanya milik Cl sahaja. So dekat sini kita ada 1 Mg dan 2 Cl. Different dengan yang ini. Yang ini 2 in front means 2 Na 2 Cl. Okay, let's say kita tambah 2 di sini. So, ini bermaksud 2 mg dan 4 Cl. Okay, 2 mg is here, 2 times mg, and 4 Cl is 2 times 2 Cl. So, all together we have 2 mg and 4 Cl. Okay, I hope you are clear enough to balance the chemical equation. Okay, now kita tengok semula yang ini. Okay, apabila kita tambah 2 di depan, so in this side we have 2 Na and 2 Cl. Okay, but here in this side we only have 1 Na. So we gonna balance this Na. Okay, then here is 2 Na, so put 2 in front the Na. Okay, remember you cannot balance the chemical equation by put the number in the formula, bukan dalam formula, tetapi you hanya boleh tambah in front the formula. Okay, so dekat sini kita dah ada 2 Na 2 Cl in this side, on your left hand side, and on your right hand side we also have 2 Na and 2 Cl. So this one is balanced chemical equation. Okay, so 2 Na react with Cl2 produce 2 NaCl is the balanced chemical equation. And how to read the sentence of this chemical equation. Okay, you kena ingat, in this one bermaksud 2 mole of Na react with 1 mole of Cl2, we produce 2 mole of NaCl. I repeat, 2 Na, 2 mole of sodium atom react with 1 mole of chlorine molecule, we produce 2 mole of sodium chloride. That is how kita nak baca chemical equation. Okay, right. Okay, kita berbalik dekat sini semula. Okay, so this is what we are going to discuss today. Okay, your textbook is on the page, I don't know, page, I'm not sure. Okay, look at example 17. Okay, burning of aluminium in air is as follow. Okay, so here you have 4Al plus 3O2 produce 2Al2O3. Okay, so that's mean 4 mole of aluminium react with 3 mole of oxygen, we produce 2 mole of aluminium oxide. Okay, now the question is, what is the mass of aluminium oxide? Okay, mass of this one produce is 5.4 gram of aluminium. Okay, is burned completely in air. Okay, so here the first thing is you have to calculate or you have to find the number of mole of the given information. Okay, what is the given information here? The mass of aluminium. Okay, so first step is you kena dapatkan the number of mole of aluminium. Okay, so we use the formula or the relationship between number of mole and the mass. Okay, so mole equals mass over molar mass. Okay, so what is the mole? Mole equals mass is 5.4 divide the molar mass of aluminium is 27. Okay, so after you calculate the number of mole then your answer must be 0.2 mole. So equals to 0.2 mole of aluminium. Okay, this is your first step. Okay, next is the second step. Okay, second step is number 2. Number 2 is mole ratio. Okay, now theoretically, secara teorinya. Okay, just now I have mentioned 4 mole of aluminium react with 3 mole of oxygen. We produce 2 mole of aluminium oxide. This is known as theoretically. Secara teorinya. Okey, secara analoginya macam inilah. Contoh, kita nak buat 1 biji kek. Okey, kita perlukan 500 gram tepung. Okey, so 500 gram tepung, 500 gram of flour. Okay, so we have 1 cake. Kita boleh buat 1 biji kek. Jika kita hanya ada 100 gram tepung, berapa banyak kek yang kita boleh hasilkan? Okay, itu secara analoginya. Okay, so how to calculate how many cake is? It's only 1/5 cake. Okay. How about kalau kita ada 1 kilogram tepung or 1000 gram of flour. Okay, so 1000 gram of flour, kita akan dapat 2 cakes. Okay, sama juga macam ini. Okay, teorinya kita ada 4 mole aluminium react with 3 mole of oxygen, produce 2 mole of aluminium oxide. This is theoretically. In our experiment or in our activity, we only have 0.2 mole of aluminium. How many mole of aluminium oxide we will produce? Kenapa cikgu cakap aluminium oxide? Cikgu tak sabitkan dengan oksigen. Sebab dalam soalan dia tak mention langsung tentang oksigen. Jadi, you boleh ignore the oxygen. Ignore. Okay. You boleh ignore saja oksigen ini. Sebab dalam soalan dia tak minta pun. Dia hanya mention about aluminium. Okay. Sekejap ya. Dia hanya mention about aluminium. Okay. And also dia mention about aluminium oxide. Dalam ini dia tak ada mention langsung tentang oksigen. Jadi oksigen kita boleh ignore sahaja. Okay. Berbalik pada yang ini. Okay. Tadi cikgu ada buat analogi. Jika satu biji kek memerlukan 500 gram tepung. Jadi, kalau kita nak buat 2 biji kek, bermaksud kita perlukan 1000 gram tepung. Okey, sama juga macam ini. Secara teorinya, kita 4 aluminium, 4 mol aluminium, okey, menghasilkan 2 mol aluminium oksida. Okey, or 4 mole of aluminium, we produce 2 mole of aluminium oxide. Okay, now we only have 0.2 mole of aluminium. Okay, so ratio dia will be 4 mole. Wait. Tak nampak pula. Kita guna pen color hitam. Okay. So, teorinya kita ada 4 mole aluminium. We produce 2 mole aluminium oxide. Okay. Now, how about if only 0.2 mole of aluminium is used? How many mole of aluminium oxide is produced? Okay. So, 0.2 divide by 4 times 2, you akan dapat dia punya number of mole is 0.1 mole. Okay, now we have the number of mole of aluminium oxide. Okay, kita dah ada number of mole aluminium oxide. That is not the answer, because the question asks you about the mass. Dia nak mass, kita hanya baru dapat number of mole. Okay, so macam mana kita nak dapat mass? Kita guna semula this formula. Okay, so mole equal to mass over molar mass. The number of mole we have calculate just now is equal to 0.1. Okay, so 0.1 equal to mass yang kita nak cari, which is the unknown one yang kita nak cari, over molar mass of aluminium oxide. Why aluminium oxide? Because kita nak tahu mass of aluminium oxide. So, molar mass of aluminium oxide is, macam mana kita nak kira? Okay, Al2O3. Okay, the RMM of aluminium is 27. So, 27 times 2 plus 16 times 3. Sorry. Okay, so kita akan dapat dia punya molar mass is 102. Okay, so here 0.1 is the number of mole of aluminium oxide. Just now we have calculate, equals to mass over 102, which is the molar mass of aluminium oxide. So mass of aluminium oxide is actually 0.1 times 102. So your final answer is 10.2 gram. Okay, alright. Okay, so that is how we solve the numerical problem of chemical equation. Okay, I hope you understand. Okay, now I will show you another example. Okay. Okay, another example of numerical problem. Okay. Okay, question number 3. Okay, question number 3. Okay, wait. Question number 3. Okay, now the question is a sample of iron 3 oxide, the formula is Fe2O3, is heated in a stream of excess hydrogen gas to produce 5.6 iron metal according to the following equation. Okay, you are very lucky because the equation given is already balanced. If the equation is not balanced, so the first thing is you need to balance the chemical equation. Okay, so Fe2O3, 1 mole of iron 3 oxide react with 3 mole of hydrogen gas. We produce 2 mole of iron and 3 mole of water. Okay, itu cara kita nak baca chemical equation. Okay, now what is the question? Okay, question is calculate the mass of iron 3 oxide. Okay, calculate the mass of iron 3 oxide. Which one is iron 3 oxide? Iron 3 oxide is this one. So, you kena dapatkan mass of Fe2O3. And what is the given information? The given information is this one. Mass of iron. Which one is iron? Iron is here. Okay. Alright. Okay, now, first one is calculate the mole of the given information. The given information is iron, which is mass of iron. Okay, so mole equal 5.6 divide the RAM of iron is 56. Okay. So, you akan dapat 0.1 mole. This is mole of iron. Alright. Okay. Next is the ratio. The ratio. Okay. Look at the ratio. Okay. Wait. Okay. The ratio is 1 mole of iron 3 oxide. We produce 2 mole of iron. Okay. Tengok soalan ini ya. Dia tak ada sebut water and hydrogen. Dia tak ada mention pun. Dia hanya mention dekat sini dia react sahaja. The reaction. Okay. Then you can ignore this one and this one. Ignore sahaja. Okay. Now the ratio is 1 to 2. Okay. You clear? Okay. I repeat. This chemical equation is 1 mole of iron 3 oxide. Okay. At 1 mole of iron 3 oxide, we produce 2 mole of iron from this balanced chemical equation. 1 mole of iron 3 oxide, we produce 2 mole of iron. Okay. So, the ratio is 1 to 2. Okay, how about if only 0.1 mole of iron is produced? How about if 0.1 mole of iron is produced? So 1 to 2, if 0.1 here, what is the mole of iron used? Okay, so 0.1 divide by 2 is 0.05 mole, if I'm not mistaken. Okay, you kena kira semula guna calculator. Okay, yang ini saya tak guna calculator tau. Saya rasa betul jawapan saya 0.05. Okay, so what is 0.05? 0.05 is the number of mole of iron. Is it? Wait. The iron oxide, sorry. 0.05 mole is actually the number of mole of iron 3 oxide. Okay, so here we have calculate the number of mole of iron 3 oxide. Is it already the answer? No, that is not the answer because the question asks the mass. Okay, so how to calculate the mass of iron 3 oxide? Okay, use again the formula. Mole, okay, mole equal mass over molar mass. Okay, mole is 0.05, okay, equals mass, which is the unknown one yang kita nak cari, divide by the molar mass of iron 3 oxide. Okay, what is the molar mass of iron 3 oxide? Okay, let's see the formula. Fe2O3. Okay, the RAM of Fe is 56. So 56 times 2 plus the molar mass or the RAM of oxygen is 16 here. Okay, 16 times 3. So you akan dapat, let's say 190. Okay, ini you kena kira juga. Kira betul-betul. Yang ini saya letak saja. Okay, so mass is 0.05 equals mass divide by 190. So mass will equals 0.05 times 190. Okay, so you akan dapat mass of iron 3 oxide. Okay, the unit is gram. Okay. Alright, I hope you clear how to calculate this mass. Okay, now let's see question number 4. Okay, question number 4. This one. Nitrogen and hydrogen gases react according to the following equation. Okay, again, they gave you the balanced chemical equation. And again, if the chemical equation given is not balanced, so you need to balance the chemical equation first before you proceed to another step. Okay, so how many molecule? Okay, the question is how many molecule? Molecule is type of particles. Okay, produced in, they give you the volume of nitrogen gas at STP. Okay, react completely with hydrogen gas. Okay, now the question asks you to find the number of molecule of ammonia. Okay. Okay, number of molecule of ammonia and given the volume of nitrogen. So, which one you need to ignore? You need to ignore is hydrogen here. Because dia tak ada kena-mengena dengan soalan kita. So, kita ignore dia sahaja. Okay, so the first step is calculate the number of mole. The number of mole of what? The given information. What is the given information? Given information is here. Volume of nitrogen. Okay, so what is the relationship between number of mole and the volume? So, mole equals to volume over molar volume. Molar volume in STP. Okay, so mole equals the volume. Okay, already in dm, so no need to convert. Okay, 6.72 divide by 22.4. Okay, let's say the answer is 0.1 mole. Okay, again, you kena dapatkan figure yang tepat. Ini saya just letak satu figure sajalah. Saya tak ada calculator sekarang. Jadi saya buat satu figure saja. Okay, so nanti bila you nak buat, you kena dapatkan jawapan yang betul. 6.72 divide by 22.4. You kena dapatkan satu jawapan dia lah. Okay, then sekarang ni saya cuma buat buat satu figure saja. Katakan jawapan dia 0.1 mole. Okay, next step. Next step is mole ratio. Mole ratio between nitrogen gas and ammonia gas. Okay, here padam semula. Okay, then kita tengok. From the balanced chemical equation, 1 mole of nitrogen we produce 2 mole of ammonia. Okay, I repeat. 1 mole of nitrogen we produce 2 mole of ammonia. Okay, just now the 0.1 mole is 0.1 mole of nitrogen. Okay. Alright. So, from the balanced chemical equation, 1 mole of 1 mole of nitrogen, we produce 2 mole of ammonia. How about if 0.1 mole of nitrogen? How many mole of ammonia will produce? So, 0.1 times 2. You akan dapat 0.2 mole of ammonia. Okay. Okay, I hope you clear. Alright. Okay, I repeat. The first one is you have to calculate the number of mole. Number of mole of the given information. Now, the given information is volume. So, you kena dapatkan relationship between volume and mole. This is the relationship between mole and the volume, iaitu Mole equals volume divided by molar volume. Okay, now the volume is 6.72 divided by the molar volume in STP, so 22.4. So let's be the answer is 0.1 mole of nitrogen. Okay. Now, from the balanced chemical equation, 1 mole of nitrogen will produce 2 mole of ammonia gas. Okay, 1 to 2. The ratio is 1 to 2. Okay, now how about if 0.1 mole of nitrogen is used? How many mole of ammonia is produced? Okay, so 0.1 times 2, you akan dapat 0.2 ammonia. Okay, I hope you clear about my explanation. Okay, next. Okay, kita dah dapat number of mole. Kita dah dapat number of mole of our question. Our question is ammonia. Kita dah dapat mole of ammonia. Now the question asks you about the molecule. So you kena dapatkan pula relationship of mole and number of particles. Why number of particles? Because molecules. Molecule is one of type of particle. So jenis particle. Okay, so mole equals number of particles divided by Avogadro constant. Okay. Alright, number of particle divided by Avogadro constant, you akan dapat number of mole. Now, kita nak cari number of particle. Kita dah ada number of mole. So, 0.2 equals number of particle divide the Avogadro constant is 6.02 times 10 to the power of 23. Okay. So, the answer is 6.02 times 10 to the power of 23 times 0.2. Okay, you akan dapat, let's say jawapan dia 1.20 times 10 to the power of 23. Salah tulis pula. Let's say the answer adalah 1.20 times 10 to the power of 23. So, the unit is molecules. Okay. Alright. Okay. Saya harap awak jelaslah dengan kita punya pembelajaran. Okay. Kenapa saya buat macam ini? Sebab kita dah ketinggalan sebenarnya. Okay. Sepatutnya kita dah masuk chapter 4. Tapi because too many programs and holiday and all that, kita dah ketinggalan dah. Sepatutnya kita dah ke depan lagi dah. Okay, so this flip classroom, I hope will help you to understand the numerical problem of chemical equation.